Hello, okay, welcome back to your dynamics of rigid bodies. So we are done last discussion with your module 1, okay, so we will now proceed with your module 2. In this module 2, we will be applying the principles of dynamics. Okay, so under this module 2, we will be having this unit 1. Okay, so in this unit 1, we will be discussing here your uniform rectilinear motion. Okay, so under this unit, you are expected to be having these outcomes, to be able to express velocity as a function of time, express position as a function of time, and express velocity as a function of time. So that is your target in this unit under module 2. Okay, so if you will try to recall, we had this topic, or we had this topic in your previous module 1, isn't it? We discussed about the types of motion, and we have here your uniform rectilinear motion. So that is what we are going to discuss under your unit 1. Okay, so it says there again, okay, let's try to recall. Uniform rectilinear motion is when an object travels at a constant speed with zero acceleration. It is known as uniform rectilinear motion. Okay, so if your motion or your movement has a constant acceleration, or I mean zero, there is no acceleration. It means your speed or your velocity is constant all throughout the motion. There is no acceleration and there is no deceleration. Okay, so that will remain constant. Therefore, we call that one the uniform rectilinear motion. So let's try to understand how is that uniform rectilinear motion. Then later on, of course, we will proceed with these two more types. Okay, and also recall in your kinematics. Okay, in your kinematics, we discuss what is velocity. Actually, that is the change, or that is the displacement, or that is the change of position with respect or divided by the time taken or the elapsed time. And acceleration is the change in velocity divided by the elapsed time or the time taken. Or if I am going to relate that one with calculus, okay, with differential calculus and integral calculus, that velocity is actually, you can consider a small change of position or a small change of displacement s with respect to a small change of time dt, ds dt. Or you can just read that one as derivative of the distance s with respect to time. Okay, and so with acceleration, you can say that is the small change of velocity with respect to the small change of time, or that is the derivative of the velocity with respect to time. Okay, so that is what we will be using. Okay, so first is your velocity as a function of time. So if you say velocity as a function of time, we will be solving the relationship of time and velocity, wherein we will try to express your velocity in terms of equation of time. Okay, so we will start here. Actually, we will be using here your acceleration equals velocity over or derivative of velocity with respect to time. Okay, so that is what we will be that is where we will be deriving your relationship of velocity and time. So if I will try to play around with this, okay, cross multiply dt together, it will go with a. You will have here dv is equal to a dt. Okay, the derivative of v is equal to the acceleration times the derivative of time. Now we want to have equation relationship, so there should be no derivatives there, isn't it? There should be no derivative. So what are we going to do? Integrate both sides for us to get rid of that derivative here, and what you did on the other side, you need to do that also on the other side. So integrate both sides. Okay, but of course for us, if you will just integrate this one, isn't it, you will end up here with, since this is integral calculus, you will end up here with plus c. If you will not, if you are applying your indefinite, I mean, yes, indefinite integrand, there should be plus c. However, since we will be having a limit, okay, we will be considering a certain time from this time to that time, so there is a limit. So if there is a limit, what are we going to apply? your definite integral. So if there is a limit, substitute your upper limit, lower limit, therefore it will cancel that constant c, or the constant of integration. So now we will try to integrate both sides. So integrate dv, and what is our limit? We are starting from the first point to the last point. So what is the velocity at the first point? That is your v sub o. That is your initial velocity, isn't it? And the velocity at the final position is your vf, or that is your final velocity. And integrating the other side also, your variable here is t. So your limit should be time. And again, since we started from this point, the time there is 0, isn't it? There is no time elapsed yet. So the lower limit of time is 0, and the time on the final point is, of course, we do not know that one, so let's just say that is time t. So that's why you have here your upper limit to be time t. Okay, integrating your dv, that will just cancel. So integral and d will just cancel. You will end up here with v. But again, please, you need to know how to apply your derivatives. Integrating your v from vo to vf. Sorry, not v. Integrating your dv, I mean. Integrating your dv from vo to vf. Of course, you will integrate that one. That will be v. The integral and derivative will cancel, but you should apply your lower limit and upper limit from vo to vf. And again, what do we recall from integral calculus? If you have limits, substitute your upper limit. So if I will substitute vf as a value of v, that will become vf. Minus, substitute your lower limit, minus always, okay, upper limit minus lower limit, vo, v will become your vo. That's why we ended up with this equation here on in your left side of that equation. And on the right side, you are integrating your a dt, and from time 0 to time t. So the same. Let's consider a there to be constant, since that is not changing, isn't it? Or actually that is 0, but later on we will deal with that. Let's say that is a constant, so you can just bring outside there a, and then integrate dt, or okay, you can put that together your a and then integrate dt. So you are just integrating dt, cancels the integral and the derivative, so that is just ap. But do not forget again, there are limits from 0 to t. So if I will apply the limits, substitute your upper limit, a t will just become t, so at still, minus, substitute your lower limit, t, the time will become 0, so a times 0, which is actually useless. Okay, so that's why that is how we ended up with that equation below, your integrals. Okay, so vf minus vo, and you have there at minus a times 0, but this will be useless, so you can erase that one. So what we are left is, okay, you can transpose your v sub o on the other side. You will have vf is equivalent to vo. Vo will become positive, plus at. So this is a relationship of a velocity and time. Okay, relationships of your final velocity, your initial velocity, and time. Since again, okay, and acceleration at the same time, but we are still on your uniform rectilinear motion. So what is acceleration? Acceleration is 0. So if acceleration is 0, that will now simplify your equation into vf equals vo. So again, as I've said a while ago, in a uniform rectilinear motion, there is no acceleration. So what you expect from the original point to the final point, the velocity are equal. That's why vf is equal to vo. Okay. So relationship of function and time. This is what actually we will be needing, since that is actually already known. Okay. Common sense, since acceleration is 0, so the velocity all throughout is the same. But we will be needing this one later on. Okay, so how about position as a function of time? Let's try now to start. We are done deriving formula from a is equal to dv dt. Let's try your v is equal to ds dt. So that is where we will start. Cross multiply your dt again on the other side. You will have ds is equivalent to v dt. Okay, v dt. And then integrate both sides again. And your variable here is s. So your limit should be, okay, we are talking here with s. from the first point, what is your distance traveled? That is your s, isn't it? Or that is your displacement. What is your displacement? You did not yet move, so there is no displacement. So your lower limit here is 0. And from a certain time t, you traveled up to this final point. What is your displacement? That is your distance s. Okay, so from 0 to s, your limit in your variable s. Integrate the other side. Okay, v there is just a constant, or that is just, yes, a constant. So our problem here is integrating your variable t. So let's bring that outside the b and then deal with the integral of dt. And again, that is t, so we are referring to time. What is the time at the original? That is 0. There is no use time yet. But at the final point, what is the time used? We do not know that one, so let's say that is time t. So just like your distances. Okay, so integrate s. Okay, by the way, this is, wait, but if we will try to do that, okay, again, since v is variable, isn't it? I mean, that should be constant. However, again, let's try to change your v. Wait, how did I do that one? V, okay. It is just a typo. Okay, so that's it. So again, why is it that there are two integration here? Because again, if v there is actually a variable but we should not be having two variables here while we are integrating only one. You need to break this down into a constant and variable t. So if you want to change your v as a function of time so that will all be variable of t, you can make use of the one that we derived a while ago. Okay, that your vf, or actually that is your, if you say vf, that is just the velocity at the final. But actually along the way, along the motion, that could be any velocity. So let's just say that is your v. Okay, v is equal to vo, or always any velocity within the motion, that could just be v. So original velocity o plus at. Okay, so that is what we will be substituting. So if you will put there vo plus at, multiply your dt, you will have here vo dt and then at dt. Okay, again, you substituted this as a value of your v. So you have there dt to be multiplied inside, so vo dt, at dt. That's why you have here vo dt, at dt. And now integrate. Still, you will be applying the integral, okay, from 0 to t. So if I were to integrate, okay, this side, integrate this side, integral of ds is s. Substitute your upper limit, s will still be s. Minus your lower limit, s will be 0. So minus 0 is useless, so that will still be s. However, in this one, okay, vo, substitute, integrate your dt, that will be t, so that will be vo t. Substitute your upper limit, vot is still vot. Substitute your lower limit, vo times 0, which is useless. That's why you still have there only vot. And then so on. You will be having here your integral of, again, a there is just a constant, isn't it? That is just a constant. Or actually that is 0, but let's take it just a constant. So your variable here is t dt. So integrating your t dt, okay, you should not be you should be careful with this. Integrating your, okay, let's say there is a there, since I will factor that out. Integrating your t dt from 0 to t, isn't it that will be, okay, integral of t dt power rule, t squared all over 2. That's why you have there your 1/2 a t squared, and do not forget your lower limit and upper limit. But if you substitute your lower limit, that is 0, so that will make this one useless. So you only have there your upper limit, which is 1/2 a t squared. That is how we ended up here with your 1/2 a t squared. Okay, so that is your relationship of position with respect to time, or position as a function of time. But in uniform rectilinear motion, acceleration is 0, isn't it? So if I will put their acceleration of 0, what is the resulting equation? This will be useless. That will just be s is equal to vot. Okay, the distance is equal to the velocity, original velocity, or the initial velocity, times the time taken. Okay, but your original velocity, since that is a constant velocity, you can just say that is v, isn't it? There is no change in your velocity because there is no acceleration, so you can just say that is v. Then cross multiplying there your t below, so actually velocity is distance over time. So this is simple. This is your simple formula in your physics. If there is no acceleration, velocity is just distance over time. Okay, or just change in distance over change of time. Okay. Once more, the other is velocity as a function of position. Okay, so we will still start with your v ds dt. Okay, you will have here your v equals ds dt. Cross multiply, or let's try now to cross multiply or bring out your dt. So you will have there ds over v. Okay. ds over v. This dt will go there, v will go down. So you have your dt as this one. Using your other equation, a dv dt, a is equal to dv over dt. Bring out again your dt there. So cross multiply, interchange them. So dt will be dv over a. Now equate. You have there a dt equation, and the dt equation equate this one. dt equals dt. So first dt is ds over v, and then the second dt is dv over a. Okay? So now play around. Cross multiply a in your ds, v in your dv. You will have here your resulting equation, and then integrate both sides. Integrate both sides. So your variable here is just v. So integrating your v, you will have again your limit from initial velocity to final velocity, and then integrating this side, you will have a ds. But again, a is just a constant there. So your ds is just your variable, integrating that one. So your variable is s. Your limit will be from 0 distance so to distance s. So the same, apply that one. Power rule again, isn't it? That will become v squared over 2. Okay, integrating your v dv is v squared over 2 using power rule. And then substituting your upper limit. Okay, if you try to do that again. So integrating VO to VF of your VDV, you will end up here with V squared over 2 from VO to VF. So substituting your upper limit, that will be VF squared over 2 and then VO squared over 2. But they are similar fractions, so you can combine that one into 1/2, or you can actually factor your 1/2 outside. Okay, you can factor your 1/2 outside, or you can just put it as VF squared minus VO squared. Okay, and then on the other side, the same. This will be A times S. Integrating the S will be S. You will have your AS. Substitute your upper, that will still be S. Substitute your lower, that will be 0. So that will be useless. So you will have here cross multiply 2 with your AS. You will have VF squared minus VO squared equals to AS. This is your third equation. Okay. So those are the derived relationships of time, velocity, and position and acceleration. So again, recall, for a uniform rectilinear motion, acceleration is 0. Therefore, if acceleration is 0, your velocity is constant all throughout. So initial is the same as final or any velocity within the motion. And at the same time, since there is no acceleration, your velocity is just equal to s over t, or distance divided by time. Okay? And keep in mind, you need to keep in mind that these are the three derived equations. Actually, this is the one that you used if you discuss this topic in your physics. Okay, you did not derive that one by integration, or if you derive that one, then that is the same. So this is these are your rectilinear equations. They call this one the rectilinear equations. You can say that your VF is V2, your VO is V1. Okay. Okay, so that is your unit 1. Let's proceed to your unit 2. Okay, so in unit 2, that is your second type, your uniformly accelerated rectilinear motion. Okay, so in this unit, you will be, okay, applying the concept of velocity to solve problems in dynamics of rigid bodies. Apply the concept of acceleration to solve the problems in dynamics of rigid bodies. And to apply the formulas in uniform accelerated rectilinear motion to solve problems related to free-falling bodies. Okay, so we will be using there the formulas that we derived a while ago. This. Okay. So before going to your uniformly accelerated rectilinear motion, okay, again, recalling, since we will be using this one still, we'll first have an example, okay? This is an example of rectilinear motion in your integral calculus, okay? So it says there that the bite shown in the figure moves in a straight line. That's why it belongs to rectilinear motion. Such that for a short time, its velocity is defined by v is equal to 3t squared plus 2t. So your velocity is now equation or a function of time. This is rectilinear discussion in your calculus, integral calculus. I mean differential calculus. Okay, so that is, if you will try to play around with this equation, you will end up with velocity in a unit of feet per second, where the time there is required to be in seconds. So the t there that you will be substituting should be in seconds, so that you will end up with a velocity which is in feet per second. Okay, so determine its position and acceleration after 3 seconds. So that using now this equation, find the position and find the acceleration after 3 seconds. You cannot just say that I will just substitute the t there, because if you will do that, what you will be having is just the velocity at the after 3 seconds. But the unknown is the position or the distance or the displacement and accelerations. So how are we going to do that? Okay, making use of your kinematics equation, v ds dt and a dv dt. Okay, first let's try to solve your position or the displacement after 3 seconds. So where are we going to get that one? Okay, what do we have is v. What do we need is s. So maybe we will be using this one. Okay, so play around again. Your v is 3t squared plus 2t. But first, let's try to play around. Okay, cross multiply dt. So ds is equivalent to v dt. Integrate both sides, but at the same time, your v will be changed into 3t squared plus 2t. So that will be plainly equations of t. Then you can play around with that. Integrate both sides. This will be s from 0 to s, or that is just s. Okay, 0 is useless. Okay, from time 0 to 3, integrate this one. This will be, by the way, if you will integrate that one, okay, I did not show the integration because that is already a foundation, or that is just the basic of your integration. So you should already know how to integrate simple equations. Okay, but let me show you here. Okay, so integral of 3t squared. Okay, integral of, I will write 3t squared plus 2t dt. Okay, so integrating that one. Okay, power rule, that will be 3t and plus 1 will be 3 all over 3. So actually 3 cancels, and here 2t squared all over 2. So 2 and 2 cancels from 0 to 3. So your resulting equation there is t cubed plus t squared from 0 to 3. That's why substituting your upper limit, then lower limit, okay? Substitute your upper limit, so t will just become 3, and then lower limit, t will just become 0. Calculating that one, that is just s, so s will be ending up with 36 feet. Okay? So that is your position after 3 seconds. So using that equation of the bike, equation of the motion of the bike, after 3 seconds, you will end up at a position which is 36 from the origin or from the initial point. Okay. Sorry, that should be B, but doesn't matter. Okay. For the second, let's solve your acceleration. So for the acceleration after 3 seconds. Okay. So we will solve acceleration. So maybe I need this equation. So play around again. A dv dt. So acceleration is just the derivative, isn't it? Acceleration is just the derivative. Okay, so I do not need to show that one here. Acceleration is just the derivative of your v with respect to time. But since you have the equation of v, isn't it? You have already the equation of v to be in terms of t. Then actually all you need to do is differentiate your v with respect to t, and that is your acceleration. So acceleration is differentiate your v with respect to t. So differentiating that one, that will be 2t, isn't it? 2t dt dt. So that will be, I mean, 2 will go down, it will multiply with 3. So that will be 6t dt over dt, or that will cancel. And then you will have here, okay, let me just show you that one. Okay, again, differentiate your v. A is just the derivative of v with respect to time. But since your v there is 3t squared plus 2, differentiate that one is 3. Differentiate your t squared will become 2t dt dt. And then minus, I mean plus 2 dt over dt. Actually, that cancels 1, 1. So your acceleration ended up to be 2 times 3 is 60 plus 2. Okay, so that's how you ended up with your equation here. So, okay, you have now the acceleration in terms of time. Since you are given time, substitute your time, which is 3, you will end up to be having your acceleration at 20 feet per second squared. Okay, so that's it. After 3 seconds, given this equation of the bike movement or motion of the bike, you will end up here with 36 feet after 3 seconds, and then end up there with 20 feet per second square as the acceleration of your bike. So what does that mean? There is an acceleration. So what do we mean by there is an acceleration? That is not a uniform rectilinear motion. Okay, it's either be uniformly accelerated, or where's that? It's either be uniformly accelerated or rectilinear movement with non-uniform acceleration. Okay, so that is for this example. Okay, now let's try. We are done deriving your equations in here, isn't it? So let's try to move with your uniform accelerated rectilinear motion. Actually, the equations here is still the same as is what we will be using in your uniformly accelerated rectilinear motion, but there will just be, of course, a little bit change since your acceleration is not 0 anymore. Okay, so we will be using this as is. Okay, you will not be cancelling the a since there is an acceleration already, and that is constant. Okay, it is since the acceleration is uniform. So this is what we derived, isn't it, a while ago? So the 3 equations of rectilinear. So uniformly accelerated rectilinear motion, okay, as observed in free falling bodies. This is an important topic in uniformly accelerated rectilinear motion. Okay. So why is it that free falling body? If you say free falling body, okay, a free falling body is an object that is falling under the sole influence of gravity. An object that is being acted upon only by the force of gravity is said to be in a state of free fall. Okay, there are 2 important motion characteristics that are true of free falling bodies. First is free falling bodies do not consider air resistance. So even in actual, there should be an air resistance, but for this topic in free falling bodies, let's let's just analyze it as plain no air resistance. Okay, so as in there is a falling body, and that is just caused by the gravity, which is pulling the body going down. And then you have here all free falling bodies. Of course, we are on Earth, so we are talking here free falling bodies on Earth accelerate downwards at a rate 9.81 meter per second squared. That is acceleration, isn't it? Okay, so that is your acceleration, isn't it? In physics, that is 9.81 meter per second squared. Okay, that is acceleration in metric. And then, or that could be 32.2 feet per second squared if you're trying to transform that one or convert that one into English unit, which is in feet. Okay, that is the equivalent of your gravity or your gravitational force. Okay, so that will be our acceleration in free falling bodies. There are no other acceleration since again we define that free falling bodies is caused by the acceleration of the gravity pulling the object down. Okay, so that is an example of your uniformly accelerated rectilinear motion. Actually, you can also have a horizontal, let's say a movement of a car with constant acceleration. That is still uniformly accelerated. Sorry. Uniformly accelerated rectilinear motion. Okay. But first, since this is the common topic here in uniformly accelerated rectilinear motion, free falling bodies, let's discuss this one. Okay. So here are your free falling bodies situation. In this first scenario, you might be okay. Let's say that an object that is the circle here, or that could be a ball, or let's say an object which is thrown from the ground going up. Okay, so that is one scenario. It is not just fall. If we say falling bodies, it is not just falling. Okay, it could be projecting or be thrown upward as long as that is straight direction. Why? Because straight direction, that is the direction of your gravity. Okay. So that could be going up. So by the way, what is DOM? You need to know this one. This is important. You need to know the direction of your motion. That is your DOM. Direction of your motion is where it is going initially. Okay, that is your direction of motion. So if you will try to throw from the ground an object upward, so the direction originally is going up. That's why this is your red DOM, direction of motion. In the second scenario, okay, you will throw that one on top, and then of course because of gravity, okay, there is a certain point that it will stop, it will slow down, it will go, slow down, and it will stop, and then again because of gravity it will go back down. And then if you are investigating there at a certain point on while it is going down, this could be another scenario, but still your direction of motion, since your original is going up, so that is your direction of motion. And then here also it could be it started from a higher point. It is thrown upward and then it goes down and down and down. So another scenario, the direction of motion is still going up because that is thrown upward. And then we have here the other the last scenario wherein that is released from top. Okay, let's say you are on the airplane and you will just try to release something there. That is now going down because of gravity. That will now just fall. And what is the direction of motion there? It did not go up. It did not go up before it went down, isn't it? It is just released. So it means it goes down. From the first minute, it is now going down. So your direction of motion is going down. Okay. So we need to follow a sign convention. Okay. So sign convention, if you say sign convention, so that you will know what is positive, negative, since we are referring here to velocities. What is velocity again? Velocity is a vector quantity, so there should be a directions, and we will define that direction by the sign positive or negative. Okay, so any parameter of your equation that goes same direction as your DOM or your direction of motion, that will be positive. Okay, so using these equations that we derive, you need to follow this sign convention. Okay, so the same direction as your DOM, that will be positive. Opposite direction as your DOM, that will be negative. Okay, always, please. You need to know that one, because even if you will substitute the right value, end up with the right value, if you did not use the correct sign, that will affect the answer. Okay. So let's start with an example. Okay, your example number one a while ago is this one in terms of expressed in terms of time. Your calculus. Okay. How about this? Okay, this is an example from physics. Okay, so the stone is thrown vertically upward from the edge of an overhanging cliff that is 10 meters above the ground. On its downward flight, it missed the edge of the cliff and hits the ground 30 seconds after it was thrown. Okay, So what is the scenario? Let's try to draw a figure. Always draw a figure for you to visualize. So first, okay, so first is you have there your stone on top of the overhanging cliff. So let's say if you say cliff, that is this one higher than your level ground. Let's say this is the cliff, and you have there the object, and you are going to throw that one upward. Okay, and as it goes back down, it did not land back on your cliff. It missed the cliff. That's why it goes down to the ground. So the question there is, okay, the question there is, okay, these are the question, but first the given there is, of course, that motion is controlled by the acceleration, which is gravity. That's why it belongs to your free fall or free falling bodies. But if you'll try to look here, what is your direction? That is the very first parameter that you need to establish. What is your direction of motion? First, initially that is going up, therefore that is your direction of motion. So technically, if there is no gravity, if you throw that one upward, it will just go up and up and up and up. It will never stop, since there is no acceleration that will affect your velocity, isn't it? So if it is started by that velocity, that will be a continuous velocity constant. So it means it will just go up and up and up and up and up. It will be lost, isn't it? But because of gravity, instead of continuing to go up, it will be controlled, brake by the gravity, and then pulled down back by the gravity. Okay, so your acceleration is actually your gravity again, but as I've said a while ago, you need to follow sign convention. What is the direction of gravity? The gravitational force is always pulling it downwards, and your direction of motion should be going up. So that is opposite direction, isn't it? It is pulling downward, and that should be going up. Therefore, your acceleration is negative. And then you have there your S, okay, distance. Okay, what is the distance? It says there that, by the way, if you say distance, that is the displacement. So the original point is the cliff, and the final point is the ground, and it says there that the cliff is 10 meters above the ground, isn't it? That is your cliff, 10 meters above the ground. So that S there is 10 meters. But again, direction of motion is going up. Your distance is from the original, it is going down to that final point, to the ground, which is going down opposite. So that is negative. And then of course, it says there that motion happened 30 seconds. So that is the total time elapsed. By the way, in time, there is no negative, positive, because there is no direction of time. Only acceleration, displacement, and velocity. Those are the only quantity in here that has direction. Yes. So the time will always be positive. Okay, do not put there a negative time. So in the first unknown there is to compute the initial velocity of the stone. So that is your V sub O. So okay, let's try. I already included here your 3 equations of rectilinear. So given, that's why it is important for you to write down the given so that you can choose right away your equation. Okay, you can choose right away your equation. So by merely looking at these 3 equations, what do we need to get is V sub O. And what do we have? A, S, and T. So look at the equations. Okay, look at the equations. If I will be using this, you know your acceleration, yes. You know your time, yes. VO is the unknown. But there is another unknown, which is VF. We do not know your final velocity, isn't it? So you cannot use this one because there are two unknowns. Unless you want to make use of 2 unknowns, 2 equations, 2 unknowns in algebra, but I do not suggest that. Go here. Let's say here, okay. Your S is given, isn't it? Yes. Your V sub O is the unknown. T is given, yes. A is given, T is given. Yes, you can use this one. But okay, later on you can see here. Okay, so later on. But in here, if you'll try to look here, your V sub F, that is unknown, V sub O is unknown, so you cannot use this one. So this is the only chance. So making use of that, substitute the given. Okay, S is negative 10. Okay, carry the signs. V sub O is the unknown. T is 30 seconds. 1/2. That is the constant. But first, before substituting that, you need to make these units coincide with each other. If you are using meters, your velocity should be meter per second. Your acceleration should be meter per second squared. If you are using their second, your time should be in second also. Okay. So that's it. So no problem since meter and seconds. All of that is meter and seconds. So we will just substitute. So playing around with this, calculate. This is just a number. This is a negative number. It will go positive on the other side. Minus the 10, that will end up with 146.82. Okay. Positive. What does that mean? Positive because that is your direction of motion. Actually, that determines the direction of motion. Okay, so 146.82, that is the initial velocity, that is the kicking velocity of the object for that to go up. Okay, second, compute the velocity of the stone as it hits the ground, supposed to be. Okay, as it hits the ground, so that is your v sub f, or your final velocity. So again, looking at these equations, you cannot make use of this since there is no final velocity. You can make use of that. Yes, since you already have VO and 2AS, A and S. But you can also make use of this. This is simpler. Okay, so that is what I've used here. Initial velocity is 146.82, A is negative, okay, carry the sign, 9.81, and T is 30. Calculated one will end up with negative 147.48. But, okay, that is not the velocity. The negative is just direction, isn't it? So your final velocity is 147.48 meter per second squared, but that negative indicates that it is opposite your direction of motion. Why? At that point already, that is now going down. So your direction is opposite your DOM. Okay? That's why it is negative. But the value is 147.48. Okay? The sign only dictates the direction of your motion at a certain point. Okay, so it is now going down, so that's why it is negative. Okay, C. Compute the maximum height reached by the stone from the ground. Okay, so from the ground, so that is your H in this figure. I put that as H. From the ground, this is your ground, that is the cliff, isn't it? So from the ground, we will try to find out what is the height from the ground that it will be reaching. Okay, so I put there that is the peak of the motion. That is the point where it is stopped, and it now goes back down. Okay, that is your peak. So get the distance or the height of that peak from the ground. Okay. So if you will try to do that, how are we going to solve that? So you know actually the height of the cliff, that is just S, which is 10 meters or negative 10 if you are using that in your equation. However, you need to know that distance from this cliff to that peak, so that all we need to do is add that distance and that 10 here, so that you will end up with the height. Isn't it? So I will just consider this movement from the cliff to the peak. Okay, so at the peak, what is now the given at the peak? The object is stopped at the peak, so it is stopped. It became at rest. So what does that mean? There is no movement. So the acceleration, I mean the velocity, there is no velocity. That's why there is no movement, isn't it? Because it is stopped. There is no velocity. So velocity at the peak is 0. That is important. You need to know that one. So making use, okay, what I used here is your second equation. Okay, by the way, you can make this to solve that one. I will show you that one later on. But first, let's solve it first by the solution that I gave you. Okay, so VF, that is 0, isn't it? Since again, it is now at the peak, there is no velocity, that's why it is stopped. And then V sub O, that is already solved a while ago, 146.82. And then 2 times A, which is negative 9.81, and the S is the unknown, so this is just a number, compute that one. This is just a number, compute that one, cross multiply, that will end up with S. This is a negative number, that will be a negative number, it will become positive. You are dividing a negative and negative. So this is 1098.68 meters. That is just your distance, okay? Sorry, I forgot to, let me just change that one so that you will not be confused. Okay, so that's it. I just changed that one to S sub P so that you will not be confused in our figure. I put that one as S sub P. It means that is the displacement from your cliff to the peak. That's why I put there sub P. So S sub P, that is the distance only from the cliff to the peak, which is 1098.68. But we are referring to the height of the peak from the ground. So add your 10, which is the height of your cliff. So plus 10, that is your height. Okay, now I will show you the other solution here, isn't it? In here we are solving V sub f, and that is the equation that we use, but actually you can make use of this. You can make use of that. So instead of using that VF equals VO plus 80, you can actually make use of that VF squared. Okay, VF squared minus VO squared equals 2AS. For in, isn't it? What we are solving there is VF. So VF is the unknown. I will transfer your V sub O on the other side. Okay, I will transfer that one since that is given, that is already solved. So VF and then squared. Okay, and then this will be 2AS plus, it will become plus VO squared. But we are solving VF, so the square root of both sides. You will have VF equals square root of 2. What is your A? Negative 9.81. What is your S? 30. My plus VO. What is your VO? 146.82 squared. Do not forget that it's squared. So what is your V sub F? I will calculate that one. Okay, I will calculate that one. Square root of it will be negative 2 times 9.81 times 30 plus 146.82 squared. 146.82. 146.82 squared, 9.81 times 30. The time is 30. 146. So your answer there is okay. So I'm sorry, I forgot. That is not time, that is S. So that should be negative 10. Negative 10. So if that is negative 10, okay, 147.40, 147.486 or 49. But actually, the difference that your answer there is 48, here is 49 because that is rounded. Okay, but the answer is still the same. So again, how about your C? If you'll try to look at your C, we are solving here your H. So that is, I think that is the only solution there. Okay, so that is for your example number 2. Let's have one more before we will finish this unit. Okay, a ball is thrown vertically upward with an initial velocity of 3 meters per second from the window of a tall building. A ball strikes the sidewalk at the ground level. Okay, 4 seconds later. So determine A, the velocity with which the ball hits the ground, and then the height of the window above the ground. Okay, so this is your figure. You need to draw your figure again. Let's say this is the window. Okay, this is the window, but it only looks like a picture. But let's say that's the window. You are looking outside, and there is a mountain. So just a symbol that could be a window, which is on a building. Okay, and you will throw a ball vertical upward, and of course that will go down since of course you will not catch that one. Okay, initial velocity, it means that is how hard you will throw the ball initially, 3 meters per second. Okay, you will throw that one upward, it will go, but after just 4 seconds, okay, it says there 4 seconds later, the ball will strike the sidewalk below. If you say sidewalk, that is below. Okay, your sidewalk of the building. Okay, so the question there is write down the given. Again, acceleration, by the way, establish your direction of motion. It says they're going up, you throw it upward, so your direction of motion is going up. So acceleration there, or the gravity, it is again opposite, so that is negative. Your VO is going up because that determines of course your direction of motion, so that is positive 3 meters per second, and then your time elapsed is 4 seconds. So the question there at A is find the velocity at which the ball hits the ground. So actually that is your final velocity, isn't it? So what are you going to use? What do we have? VO and T. So actually, and A, you can make use of this. This is the simplest equation. Okay, this is the simplest equation. So can you use this one? Actually, you cannot use that since S is unknown and there is no VF since that is what we are solving. Here you have your VF, but you have the S under unknown, so you cannot use that one. You only use this one. Okay, VO, that is 3, and then A is negative again. Consider the sign times your T, which is 4. You ended up with negative 36.24, but that negative only, okay, means that that is opposite because supposedly that's going up, but at the final point that is now going down. So opposite the DOMs, but the velocity final is just 36.24. Okay, the B, height of the window above the ground. Okay, the question, that height of that window above the ground or from the sidewalk. Actually, that is the S in this figure. I put that one as S. So the unknown is S. We already have VF and we already have this one. So what can we use? You do not have here S, so you cannot use that one. Here, you have VO, yes. You have T, yes. You have A, yes. You have T, yes. You can make use of that. In here, you have VO, yes. You have A, yes. You have VF, yes. You already solved that one. And the unknown is S. You can also make use of this. But, okay, that BF, we already solved that one. We just solved that one. So, you need to make use. You can make use of this too. However, it is safer for you to make use of this second one. Why? We are just using the given. In here, we are using something that we just solved. So maybe if you made a mistake here, that will affect your answer in your B. But if you are sure of that, then that should still be the same. Let's first make use of this, and then I will show you that that will be the same. Okay, so VO is 3 and then T is 4 seconds. 1/2, your gravity is negative 9.81 and then T is 4, okay. Ended up with negative 66.48. The negative only stands again of the distance is just below the original point, isn't it? The distance is below your original point and you are supposed to be going down. So that is why it is negative, but the distance is just 66.48. Now I will show you that you can make use of this second one. Okay, you can make use of that second one. Bf squared, okay. Bf squared minus Bo squared 2as. What are we solving is S. Play around. So S, okay, Bf, what is your Bf? We already solved that one to be 36.24 squared. And then your Bo is of course 3 squared all over your 2. And then your A, your acceleration is negative 9.81. So S is, okay, let me just compute that one. 36.24 squared minus 9 over negative 2 times 9.81. 2. So your answer is negative 66.48, or simply again, this is just the direction. So 66.48 same? Yes. So it is the same. Therefore, you can make use of that. So that's it for the uniformly accelerated and at the same time free falling body. Okay, uniformly accelerated, it could be a horizontal movement or it could be a falling body, but this is more complicated, the falling body, because there is going up, going down. You need to know your DOM. But if that is just a straight vertical horizontal, then there is no problem. Okay, there is no problem if that is just straight horizontal. Okay, so that is the end of this unit. You have actually one more unit, but I will separate that one since this video is already too long. So, but before you will go there, that will be our next topic. But before you will go there, please try this one. It should be to be submitted. This is actually your first activity. Okay, is this your first? I think so. Yes, this is your first activity. Okay, so read that one and then accomplish, draw the figure, show the complete solution. Of course, should end up with correct answer. Okay. So let's review. This is the important concept that we discussed here. Free-falling bodies have constant acceleration because of gravity. Yes, you only have there a uniform acceleration, which is the gravity. Consider the direction of motion as the positive direction. I explained that one a while ago. Consider the direction of the initial velocity as the direction of motion. That's what I'm saying. The first movement or the first direction, that is your original, which is your direction of motion. It will only be affected by gravity. It's either it will just go down and down, or since it is going up originally, it will now be brought down by gravity. So the original velocity dictates the direction of motion. And then acceleration due to gravity is always downward. Okay, of course, unless you have a gravity on top. Okay, so that's it. If you have any question, comment that one below the video, or we will be discussing that one on our live meeting. So thank you very much. Okay, credits to the slides, template, and your photographs. Okay, thank you very much for watching.